Yes, that's fine.
Okay. So good morning, everyone. I'm from Analytics, and today I am introducing drMAIC, a doubly robust R package for reproducible matching adjustable indirect comparisons in HTA. This is a methods and tooling talk. I will spend most of the time on why standard MAIC has gaps, how drMAIC closes them, and what the output actually looks like in practice. And then I will open it up for discussion. So there are four sections plus our discussion at the end. First, the HTA evidence gap and why we need indirect comparisons at all. Second, standard MAIC, what it does well and where it falls short. Third, drMAIC itself, the doubly robust framework and what it adds. And fourth, from analysis to HTA impact, where I will walk through a simulated NSCLC example showing the full output. I will close with the key takeaways. So let's start with why indirect comparisons matter in HTA in the first place. HTA agencies need evidence comparing competing treatments, but direct head to head trials are often missing, especially in oncology, rare disease, and precision medicine. Sponsors typically have IPG for their own trial, but only published aggregate data for the comparator. If you compare the two naively, differences in the patient populations bias the result. Population adjusted indirect comparison methods were developed precisely to reduce this bias and support more informed reimbursement decisions. The real challenge here is not comparing treatments, it's comparing them across different populations. Now let's look at the most widely used for of these population adjustment methods, standard MAIC. So MAIC adjusts for cross-trial population differences by reweighting patients in the available IPD study. So the weighted sample matches the comparator study's published baseline characteristics. If you follow the diagram, I start with IPD study A, which has detailed patient level data, and published study B, which only has aggregate baseline characteristics. I reweight the IPD so it forms a balanced population that approximates study B. The question MAIC is really answering is this: what treatment effect would we have seen if trial A had enrolled patients similar to those in trial B? So, MAIC adjusts for baseline differences, mitigates confounding from treatment effect modifiers, and gives more decision relevant comparisons than naive indirect methods. Standard MAIC has three steps. First, I select baseline variables that are prognostic or treatment effect modifiers. Then I estimate a weight for each IPD patient so the weighted averages match the published comparator values. And finally, I estimate treatment effects in the weighted sample, checking covariate balance and effective sample size or ESS. The assumptions on the right are the load bearing walls of the method. No important unmeasured effect modifiers, adequate covariate overlap, transportability, consistency of treatment effects, and correct specification of the weighing or outcome model. That last one is the assumption drMAIC directly targets. So it's worth keeping in mind over the next couple of slides. There are really two buckets of problems here. On the methodological side, there are a few issues. Weighing model misspecification can bias the estimates even when the covariate balance looks fine. Large population differences can produce extreme weights, and those shrink the effective sample size and inflate uncertainty. And the method only holds if you have captured every relevant prognostic factor and effect modifier, which you can never fully guarantee. On the practical side, the analysis is often bespoke code written by individual analysts. So implementations end up inconsistent. Diagnostic practice varies a lot from one organization to the next, and that lack of standardization creates real barriers to transparency, reproducibility, and auditability, which are exactly the things HTA reviewers are scrutinizing more and more. The bottom line is that successful matching does not guarantee robust estimation, and that's the gap drMAIC is built to close. So, how do I address both sets of challenges, methodological and practical, in a single tool? That's where drMAIC comes in. drMAIC was designed around three objectives: each map directly to the limitations I just covered. The first is to improve robustness by implementing a doubly robust estimator that combines inverse probability weighting with outcome regression. So I'm not relying on a single model being right. The second is to improve reproducibility by replacing fragmented analyst specific workflows with a transparent auditable pipeline that's applied consistently across projects and organizations. And the third is to standardize diagnostics by embedding balance evaluation, ESS, sensitivity analysis, and confidence interval estimation in a single framework rather than leaving it to individual analyst judgment. The objective here is not automation for its own sake, it's better evidence generation. So, in one line, drMAIC brings estimation, diagnostics, uncertainty assessment, and reporting together in a single HTA focused R package. One package, one workflow, one reproducible analytical record. There are four pillars on screen: doubly robust estimation and balanced diagnostics, comprehensive analytical and sensitivity tools, and HTA ready outputs and reporting. The next few slides unpack each of these in turn. This is the core methodological contribution. So I will spend a little more time here. Conventional MEIC relies exclusively on inverse probability weighing, which means estimation accuracy depends entirely on that weighing model being correctly specified. You essentially get one chance to get it right. drMAIC adds an outcome regression model alongside the weighing model. And that combination is what's called a doubly robust estimator. It gives valid estimates if either the weighing model or the outcome model is correctly specified, not necessarily both, and that materially reduces the reliance on any single model component. Put simply, standard MAIC has one opportunity to be correct and drMAIC has two. Robust HT analysis needs more than a treatment effect estimate. It needs evidence that the assumptions were actually checked, and drMAIC bakes that in rather than treating it as optional. There are four integrated categories: guidance alignment following NICE TST 18, the Cochrane Handbook, and SPOR. Balanced diagnostics using standardized mean differences and love plots. Weight assessment covering effective sample size and weight distributions, and robustness and uncertainty with bootstrap confidence intervals, e-values, weight trimming, and leave one variable out analysis. It also reports optimizer convergence and the contribution of the doubly robust augmentation term explicitly rather than leaving them buried. So this is the end-to-end pipeline and it runs left to right across the 5 circles. I start with IPD plus aggregate data, move into variable selection for prognostic factors and treatment effect modifiers, then into weighing and estimation, where I calculate balancing weights and fit the doubly robust model. From there, I move into diagnostics and uncertainty, covering balance, ESS, bootstrap CIs, and sensitivity analysis. And finally, out to HT ready outputs, including structured summaries, submission text, and technical appendices. The key point is that this replaces multiple disconnected scripts, spreadsheets, and reporting tools with one reproducible workflow, which is exactly what I will show in the worked example next. So this is a quick setup before I show you the actual output. I am using a simulated NSCLC dataset to run the full drMAIC workflow end to end. There are 4 output categories: population adjustment, diagnostic evaluation, uncertainty and sensitivity analysis, and reporting. The next slide shows the actual generated output. So I will show you exactly what comes out the other end. This slide is really just the contents page for that. So this is the actual drMAIC report output, and I will pick out a few highlights rather than narrate every line. One quick caveat before the numbers. everything on this slide comes from a simulated NSCLC dataset, so it's purely illustrative of the workflow. The 0.0726 is on the log odds scale. Exponentiating it gives an odds ratio of 1.0753. It's a property of simulated data, not a real treatment effect. First, the report header is auto-generated and aligned to NICE TSU TST18, Cochrane and SPOR, which makes the reproducibility and auditability point concrete. Second, on weight estimation, the effective sample size retained is 149.4 out of 200 patients, about 74.7%, which is a reasonable retention rather than a collapse. Third, in the treatment effect estimates table, standard MAIC and drMAIC both land on odds ratio of 0.0726 here, with a small doubly robust augmentation term of about 0.0038. That's expected in the simulated example because both the weighing and outcome models are reasonably well specified. And the augmentation term is the visible proof that the doubly robust correction is doing its job even when it's small. Fourth, the love plot shows the shift from the red pre-weighting markers to the green post-weighing markers, crossing the 0.1 SMG threshold, and the e-value of 1.23 gives us a sensitivity check on unmeasured confounding. That's the worked example. Now let's bring it all together. I will keep this to 3 quick sections. The key takeaways: drMAIC is a doubly robust framework that combines inverse probability weighing with outcome regression. It addresses the key limitations of a standard MAIC I covered earlier, and it integrates estimation, diagnostics, and reporting in one place. In terms of impact on HTA, it improves transparency and auditability, strengthens the robustness of indirect comparisons, and increases confidence in the evidence used for reimbursement and market access decisions. And drMAIC is now published on CRAN for wider accessibility. Looking ahead, the future directions include expanded reporting capabilities and applications in privacy preserving evidence synthesis, which gives a good sense of where this is heading. These are the foundational references. The key ones are Signovich and colleagues from 2012, which is the original MAIC paper, and Filippo and colleagues NICE TSU TST18, which is the population adjustment methods guidance. Bang and Robbins from 2005 is the foundation for doubly robust estimation. So that's all. Thank you for all your time. You can find the package on GitHub and on CRAN, and feel free to reach me out on my email ID.
Thank you very much, Stefania. Dawn, do you want to ask that one in person?
Yes, that's absolutely fine. Yeah, so you're talking about doubly robust methods and using outcome regression. So could I just check exactly what it's doing? So is it actually conducting simulated treatment comparison and make methods and then combining the two for the doubly robust method? Can you see just the simulated treatment comparison and the make results separately?
Yeah, so we are combining the standard MAIC model with the G computation STC model, and that makes it doubly robust augmented estimator. So here we are defining two models, one from the standard MAIC IPW, inverse propensity weighting, and then from the G computation, the another model.
Yeah, thank you. And can you see the two results separately outside of the doubly robust framework?
Yeah, can you repeat, please?
Sorry. Can you see the results of the simulated treatment comparison and the make separately outside of the doubly robust framework where you're combining the two?
Yeah, so results are almost similar because this is a simulated example and we have the augmentation term, which is around 0.0038. So it's a visible proof that the doubly robust correction is operating even when it's small. So yeah.
Brilliant. Thank you.
Thanks. Feel free to reach me out on my email ID for more questions. I will be happy to answer. Thank you.
I just had one question myself.
Yeah.
There's kind of a few, I understand that you're doing the doubly robust, and I very much see the benefit of that. but there are a few packages for MAIC now kind of around, other than the doubly robust element. How would you say your package compares to those? Because you do provide, did you say the MAIC, plain MAIC and plain STC?
Yeah, so the existing packages don't provide the like the outputs we need for HTA submissions. Like they didn't provide the standard mean difference in a format of a table, and the plots which I have shown for the sensitivity checks and the e-value for the sensitivity analysis. So there are some of the diagnostics where this package is different from the other packages which are existing. So yeah, for example, like in the previous packages, we don't have the SMD. We have to calculate the standard mean difference from the baseline characteristics. We have to calculate the bootstrapping estimates as well. But in this package, you have all the outputs in one go, in one package.
Brilliant, thank you.
Welcome.
Well, I'm sure if anyone thinks of a question later on, they can ask you in the chat. Thank you very much.